Here we will see thread priorities and thread scheduling in C#. In a multi-threading environment, each thread has its own priority. Whenever we create a thread in C#, some priority is assigned to it. A thread's priority shows how frequently a thread gains the access to CPU resources. The thread class provides the thread priority enumeration is under system.threading namespace, which is responsible for specifying the scheduling priority of a thread. Every thread has a priority in the range between thread priority.lowest to thread priority.highest. There are basically 5 types of thread priorities: lowest, below normal, normal, above normal, and highest. By default, each thread has priority normal. The Windows operating system supports a concept called time slicing that enables threads of equal priority to share a processor. Without time slicing, each thread in a set of equal priority threads runs to completion before the thread's peers get a chance to execute. With time slicing, each thread receives a small processor time called quantum during which the thread can execute. At the completion of quantum, even if the thread has not finished executing, the processor is taken away from that thread and given to the next thread of the equal priority if one is available. The job of the thread scheduler is to keep the highest priority thread ahead running at all times. And if there are more than one highest priority thread present, thread scheduler ensures that all such threads execute for a quantum in round-robin fashion. This figure shows multi-level priority queue for threads. Here thread A and B each execute for quantum in round-robin fashion until both threads complete execution, since both the threads have highest priority. That is, A gets time to run, then B gets time to run. This process continues until one thread complete. Then the processor devotes all its power to the thread that remains unless other thread priority started. Then thread C is started. Then D, E, F each execute for a quantum in round-robin fashion until they all complete executions, since all these 3 threads have priority below normal, that is equal priority. This process continues until all threads run to complete, and then process G is started.